Welcome to part 2 of learning the Nix programming language. There's a part 1, you can look for it, where we learned really basic stuff and how to do an attribute set. Today we are learning the rest of what's in this section. Hopefully, we'll see how far we can get. We start with the let and in. So let's read it together. Also known as let expression or let binding. Sorry for my voice. I'm watching a cat and maybe I'm slightly allergic. Let expressions allow assigning names to values for repeated use. Example, let a equals 1 in a plus a. All right, let's try that out. So we'll get rid of this stuff. Let a equals 1. I think there's a semicolon here. Don't look at the screen when I'm doing it. I'm not copying. I'm trying to remember it, just in case it gives you some ideas on how to do it. I think there's no semicolon here. So let's see if that runs it. No, Nix instantiate, I think it was called. Was it eval? 2. All right, perfect. So what's happening here is you can probably, let's look at the screen again, right? It looks like we're assigning basically values to variables here in this section, and then we can use them in the in section. So nothing too extravagant here. Detailed explanation. Assignments are placed between the keywords let and in. So notice they say assignment, so it looks like we can put several in there. In this example, we assign a equals 1. After in comes the expression in which the assignments are valid, where assigned names can be used. In this example, the expression is a plus a, where a refers to a equals 1. Okay, I think that's pretty clear. Names can be assigned in any order, and expressions on the right of the assignment can refer to other assigned names. Oh, cool, so we can put them out of order. Let's try that out. So I can do b equals a plus 3 or something like this. And then we can add the 2 together. And we will run this. 5. Is that right? A is 1 and b is 1 plus 4 is 4. So 1 plus 4 is 5. It's way too early for me. It's literally 3 p.m. here, but it's early for me. I woke up super late. So, this is really just like my brain's barely working. Detailed explanation. I don't think we need this. I think it's pretty clear. As always, I have a Discord channel, Discord server that you can join. It's in the description. If anything is unclear, let me know and I'll be happy to help out. Oh, look at this. We're making a list here. Let's make a list out of these let things. So we will make a C and we will make it a plus 2. Oh, let's make it a plus 1. So we have a is 1, b is 4, and c will be 2. And then here we make a list. They're just separated by space. And so it should print out the list here. Oh, look at that. So it's lazy evaluated. So it said, oh, I know A because it's direct. It's like directly A equals 1. We told it what it was. But B, B is needs further calculation. And in the last section, we learned that Nix instantiate and the REPL both use lazy evaluation. So it won't actually do it unless we give it the strict option, I think. And now we have 142 just as we expected. All right, perfect. Only expressions within the let expression itself can access the newly declared names. We say the bindings have local scope, right? So anything outside of it can't access it. This looks like a very contrived example, but let's get the idea of this. They're doing an assignment uh, over here, so this is going to resolve to 1 because let x equals 1 in x, so this whole thing returns a 1, and then a equals 1. Let's just do that part first so that we see that it actually works. Let x equals 1, and then we need the semicolon in x. And we need this semicolon, I think, is to close out this a. Yeah, so, and now we can print out a list with just a in it. So it's a list with just a in it. But now I can't refer to x anymore because this is only valid within this let expression. So once it's done, this x no longer exists to the outside world. There we go. Perfect. But obviously you can put a here and this will work. Oops. Yeah. Oh, well, I don't actually use b. 1, 1. B is the same as a. Attribute access. Attributes in a set are accessed with a dot and the attribute name. So we've done lots of attributes before. If you remember, we just had things like, just like this, I think. A equals 1, B equals 2. And then when we evaluate this, it just gives us back the attribute set. So now we're going to define the attribute within a let. So we'll say something like my set equals, and we have this set. Does that look right? And I think we need yeah, we'll need one of those. And then in, and then we want to access, well, first let's just print out, let's just evaluate and show the my set. I think this should work. Yeah, so it prints a equals 1, b equals 2. And now we'll just try to access a. So it should just show 1. Yeah. And now we can do something like make a new list even. My set A and my set B. And we get 1 and 2. So that's how we access things. Yeah, I think that explains it. We can put anything here, like we should be able to just even make another set that's exactly like it. Kind of funny, like we can do A equals my set dot A, B equals my set dot B, and then we should have the same thing we started with, even though it's kind of like redundant, right? Okay, hopefully that made sense. Where were we? Okay. Accessing nested attributes works the same way. So we have a nested attribute set here. Let's make something similar. Oops. A equals B equals C equals 1. And then we will just print out, let's just print out A to start with. Oops, I definitely did something wrong. Right, each of these assignments, whenever you have an assignment, it needs to have a semicolon at the end of it. So whenever you do have an equal sign, this is the next thing, this closes the parentheses, and then you have to put a semicolon afterwards. So let's see. Oh, there is no A. All right, A equals B equals C equals 1. Oh, I was wondering why I didn't have the lazy evaluation issue. Right. So if we didn't have this strict, we wouldn't see, we would just see A. Now I want to access the value for A dot B dot C, which should be the number 1. And we will see what that is. 1. Here, I think if I don't have strict, it should work because I'm forcing it. You see, like, if I did A dot B, I think, oh, right, because, well, A dot B, B contains, I wonder why it actually doesn't say code there. Yeah, I guess because it's the same level as the last node. Anyway, it doesn't matter. We will continue. Yeah, we did this. The dot notation can also be used for assigning attributes. Example, A dot B dot C equals 1. All right, perfect. So it's like a shorthand way of doing this. Let's see. A dot B dot C equals 1. Oh, no, they're just making it a set. Don't need to let. All right, oops. I can't type. That was awfully hard, wasn't it? And I forgot the semicolon. It's way too early. The semicolon belongs inside right after the equal sign. Guys, forgive me. All right, there we go. A equals B equals C equals 1. So it's just a shorthand for making attribute sets in here. It knows that this B must be an attribute set, and it knows that C must be an attribute set because dots are used for attribute sets. So it's just making our lives easier. So that's pretty cool. Width. All right. The width expression allows access to attributes without repeatedly referencing their attribute set. Example, we make an attribute set called A, and then we say with A, XYZ. So it's going to basically put the A in front of, it's going to do an A dot in front of each of those items in the list. I guess after the with, you have the variable name, then you have a semicolon, and then you give it like a list, I think, all the time. That's my guess. So my audio cut out here. I have no idea why. So you're going to get a voiceover for the next 3 minutes. It's really funny watching myself because, God, do I type slow? I hope it's just the morning. So yeah, we're trying to just create the example here out of memory to see if it's going to work. And so this looks like an attribute set with XYZ. And now we're going to add the with part within the in section of it. So with A here means that we're going to be using the variable A up on top. There could be many other variables. So with A specifies which one. And then we add XYZ, and then it works. So then I think I'm trying to figure out like, okay, what is the syntactical sugar for? Because we can obviously do this without the with command. Let me make sure audio is working. Yep. And so I figure out that, yeah, this is just saying a dot x dot a dot x, a dot y, and a dot z. And so that's all it's translating it into. And then I look at the documentation and say, oh, that's what it's saying too. It's just equivalent to ax, ay, az. And now this section is saying that all the attributes that we use within the with statement are only available for that with statement. So we can't use it once that with statement is done. So here you see the with A, and then when C tries to use X, X no longer is in scope, so it doesn't work. So now I'm going to type that in, I assume. I think I'm going to type in just a version that works first, because here we have an attribute set rather with on the inside. So let's just make sure that we have this attribute set that works. I have no idea. I seem to talk a lot while I'm like coding. I have no idea what I'm saying. All right. And that worked. So we have the attribute set with B inside of it, and B is the list 1, 2, 3. Now we're going to try to illegally access X. And and then here we get an error saying that X is undefined. Now I'm trying to like, hey, can I just like use with without a list? And no, it looks like with always takes in a list. All right, so now we're going to look at inherit, and I think the audio kicks in again. Inherit is shorthand for assigning the value of a name of an existing scope to the same name in a nested scope. Back to your regular programming. Name in a nested scope. It is for convenience to avoid repeating the same name multiple times. Am I dyslexic? Why do I have a hard time reading? Let x equals 1, y equals 1 in inherit x, y. What a strange example. All right, so it's just bringing down x and y here inside this attribute set, I guess. Um, okay, let's do it. Uh, so we get rid of the attribute set on the top. We just have x and y. And then over here, we want to inherit. So we are in an attribute set here, and we're bringing the x and y from outside into the attribute set. I think that's right. All right, so otherwise, we would have had to type x equals x, y equals y. I think that should work. Yeah, and just saying inherit xy, I guess, is a little bit easier. So we're just copying. This is just, I guess, ugly and kind of silly looking. X equals x. This x is a new x, the attribute keyword name, and this is the value, and this x refers to the x up here in the let. So instead of doing this, we're just doing inherit. All right, makes sense. It is also possible to inherit names from a specific attribute set with parentheses, inherit blah, blah, blah. So we don't inherit everything, we're just inheriting from names from a specific attribute set. I see, okay. So it's like the parentheses is just telling it the attribute set that you want to inherit from, and then you still give it the list of things you want to inherit. All right, so we have to turn this into an attribute set. X equals 1, y equals 2, and then inside here we want to inherit specifically from a x and y. All right, that makes sense. Because if we just do x and y here, it won't know that there is no x and y at the top level here, just a. So let's see, this should fail, right? It's like I don't know x, but I assume we can do a dot x, a dot y. Oh, sorry. Oh, maybe that naming doesn't work. That syntax doesn't work. All right, so this is basically what it's letting us do, because otherwise we have to type a dot x to bring down this value and y equals a dot y. So instead it lets us, instead we're basically doing inherit a, is there x, y? Yeah, it's the same thing. So this is equivalent to this. All right, makes sense. Oh, I really should probably look a little bit ahead. It's kind of good to figure it out on your own, you know, try not to go too far ahead, because just making yourself like trying to understand it just I think is helpful. Inherit also works inside let expressions. Ooh, okay. Let inherit x equals 1, y equals 2, x and y. These are such contrived examples. I think it actually makes it harder to learn because they're so contrived. I don't know what you guys think. Okay, let's try it. Inherit. And then inside inherit, we're doing, I see. So we're using the parentheses thing. So this is basically, remember, this is like the scope we want to inherit from, right? We passed a before, which was the attribute set. But instead of passing a variable which contains the attribute set, we're going to give it a literal attribute set. So x equals 1, y equals 2. And from these guys, we want to pull out x and y. So this is going to make an attribute set that is basically x and y. And then we can just print x and y here. So yeah. So if you remember the previous one we had here where it said inherit a, this was an attribute set. That was this. So now instead of that, we're putting it directly inside of it. And we're saying pull it out. So then out of this, we get just the x, it just repeats itself. It's basically the same thing. I wonder if I can do something like a equals inherit. Oops, and then do a. No, I guess I can't. Unexpected inherit. Yeah, and I also didn't have an extra, so I guess we can't do that. Anyway, I'm still having a little bit of a hard time knowing how I would really use that. I guess if your let expression had nested attribute sets, then you can pull them out that way. We'll see. Oh, here's detailed explanation. Oh, it says it. While this example is contrived, in a more complex code, you will regularly see nested let expressions that use names from their outer scope. Here, we use the attribute set x equals 1, y equals 2 to have something non-trivial to inherit from. The let expression inherits x and y from the attribute set using the parentheses, which is equivalent to writing, yeah, okay. Right, that makes sense. Well, we'll see if we end up using any of that later. And it's been a little bit, oh, it's almost been 30 minutes, so we'll stop here. And then after this, we got string interpolation, file system paths, and indented strings. That will finish off the named and values section. And then we go straight to functions, which should be, well, it's a functional language, so we'll get into the meat of what's fun in this language. Hopefully we're learning stuff. Let me know in the comments, like and subscribe. Thanks.